Hello, welcome to the video. So today we're looking at this. This is a Harlequin ZX Spetrum, and it's a recreation of a 128K, and it fits in a regular 48K case. So Neil sent this over to me from Retro4U. Cheers, Neil. And he's built two of these, and he's had issues with both of them. So yeah, he sent me one, and I'm going to build it up, and we're going to see how we get on in a bit. Right, so here we are, part way through this Harlequin build. As you can see, I've got quite a few passives down. There's nothing really funky going on here, it's just basic through-hole stuff, apart from this. And this is a diode network. So you've got to build it up out of 5 diodes, 4148s. So yeah, onwards. Okay, so here you can see we've got a lot of the passives on, a couple of chips. These ones I've put on first because we've got to put in between these and the carriers. And I've used open frame carriers, as you can see, purely because it's got to clear the chips, obviously. So yeah, it's proceeding well. Yeah, onwards and upwards. Here we go. Okay, so here you can see I've got nearly all the sockets on. I'm missing one up here, and it's taken, I know, roughly about an hour, which isn't bad at all. As you can see here, if I just flip this over, there we go. These whiteboards show up everything, and even though I've just soldered it and it's uncleaned, it still is not that dirty, really. And that's because I've been using a different type of solder. This one, Mechanic HXT100, and I'm using a really high diameter 1.2 millimeters, which is really thick, as you can see here, and you can just power through it. So yeah, all good. I don't think it's gonna take too long to finish this build now. I'm just waiting on some other components to turn up, and then we can populate it and get it tried. Superb. So yeah, right, so here we are. The board is almost complete. Unfortunately, I'm still waiting on a few components. There's a couple of capacitors missing over here, the connector, the power connector, and the 5-volt switching regulator. I'm waiting for that to turn up. But other than that, it's a very simple build. It didn't take too long at all. I think I'm going to say maybe 3.5 hours to get it to this point. So yeah, that's pretty good. Once I get it, I've got all the chips ready, so yeah, I'll be ready to power up. So yeah, okay, so the missing components turned up. I've got the resistor networking, the DC to DC power supply, a couple of other dodgy caps that are small picofarads. So got 10 puffs down here, 27 over there, just for the timing circuits. So yeah, this is the last of it. All I've got to do now is get it all installed, get the chips in, and program up the ROM, and we should be ready to power it up, except I don't have a power supply yet. Hey ho. Here we are. We've got the Harlequin sitting on top of an Engo, sitting on top of an MSX, sitting on top of a C128. I'm all plugged in, ready to go. I'm going through just a regular, I'm using an oxygen-free cable. That's why it's green, blue and red, but it's plugged into the composite on the back of the telly. I'm going through, yeah, this is a component 3-way output used on a 64 thing I've got. So, but that's the same thing as tip ring sleeve. So yeah, I'm all plugged in, ready to go. So here we go. Got the right polarity center negative power supply. Which is on. Well, that was underwhelming. Okay, Jesus. All down should be the diagram. Let's try it all up. Jesus. Nothing. Dead's the door now. Alright, I'm going to check the chips in an 866 programmer, make sure they're logically okay, and then we'll go from there in a bit. Right, okay, we're back again. So all plugged in the same arrangement. Yeah, there was 3 Duff chips in the 866. So yeah, here we go. We're all powered up. Let's see if we get anything on the screen. Oh man, still nothing. The joys of building your own computer. Right, so what we're going to have to do now is start from basics and start probing it out. So I'm going to get the scope fired up and then we'll go from there, shall we? Shortly. Alright, so here we are back again. I've got the scope powered up, schematic. Let's find out what's going on with this. So to begin with, the first thing we're going to do is make sure that we've actually got voltage and clock. I think that's probably the first kiddie here. So I've got to work cack-handedly because I've got my phone on this weird tripod. No, it's not a tripod. It's like a movable swan neck, so it could wobble a bit. So this is 9 volts. It should be center negative. So let's just, I've also put the end go away, so I'm perched straight on top of the thing. Okay, what do we get there? Oh, that's not right, is it? Yeah. Can't really clock into that like that. Oh dear. Right, so he fell over at the first hurdle. Luckily though, I've got my very trusty fluke. So here we go. Should be able to read that okay on the camera. It's not easy making YouTube videos, really ain't. So center is negative, like this. Positive on the outside, 9.43 volts, lovely jubbly. Okay, so we know we've got the right voltage. There's no load on it, and it's a cheapy switcher type power supply, so it's going to be a little bit over. Right, so here we go. Next thing we're going to do is bell out the CPU, I think. So let's power it up. Boom. Got nothing on the TV. So the first thing we want to do is take pin 1, 2, 3, 4, 5, 6. And as you can see on the scope, we've got... That's not right. That's not right at all. I'm not talking about the ringing either. 2.7 megahertz. That's not right. I thought a Specky ran at 3.5. Okay. Right. Let's have a look what we've got here then. So, looking at this schematic, that's a bit busy, isn't it? Right, we've got 4 megahertz, is it up here? Let's get this closer, right here. And there. There's another one. 28 megahertz. Now I've seen this type of thing before on the MSX. If you look at my video for the floppy disk controller, that had a similar type of arrangement for generating a clock. I was using it, some gates to do it. Yeah, that's 28.3 megahertz here. It's being cut in half to 14, and it's being decimated down again. Well, half of 14 is 7, and half of 7 is 3.5. So that's not right. Why are we getting 2.6? What is this? U13. Alright, so on pins 2 and 3 here, we should have, albeit an inverse, but we should have 28 megahertz. Alright, there we go. I'm gonna have to put these on for a second, because being over 50, my eyesight is terrible. Alright, U13, where's that at? Okay, pin 3. What we got there? 20.6 megahertz. 20.7. Ah, ladies and gentlemen, we have a winner. Winner, winner, chicken dinner. Why is that too slow? Right. That should be going at 28 megahertz. I don't have a spare. These are HC chips as well, so I bet we're chip limited. What I've known before is certain types of chips work better than others. This should be, this chip came from Neil, and he got it from DigiKey, so it's not a fake chip or nothing. But I reckon we're at the top end of what it can oscillate at. These, like on the other, the trouble I had with the MSX floppy drive, changing it solved the problem. The thing is, you really want an unbuffered chip to use as an oscillator, especially at 28 megahertz. I mean, that's right on the outside of what the chip can do. So 28 megahertz is 30 something nanoseconds. So you're really going to be pushing it. Right. Bloody hell. Right, okay. I'm going to have to have a look at my parts bin. Let's, yeah, I'll reconvene in a minute, see what I can find. Back on again. Right. I tried an LS chip in there, 'cause it's an 04. Yeah, that didn't even get up as high. So, yeah, I did find an AC variant. So, AC04. That should be fast enough. So, let's just get this chip pried out. Drop in an AC. Oh, I don't like this. Can't get in there. Have I bent a pin? I don't like the look at that. No, I didn't bend a pin. Looks okay. Right, let's try powering this up then. Ah! Well, there's no point measuring that with a scope. Obviously, we've got something. Let's just move this round. Okay. Well, we've got something on the screen. Let's reset that. Does that work? No. What's going on here? Right, that's not good. We've got something though. Let's push that down in the socket better. Okay. All 3 dip switches towards this side of the board should be diagram. Oh, right. Well, at least we're getting somewhere now. That's a lot better. Okay. Whoa! There we go. Right, so look at that. Is this what it's meant to be doing? Yep. Go, 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 go. Oh, man. All right. Okay, I'm going to have to power down, get the SRAMs. I think it's this skinny one. I'm going to have to get it tested and find out what the hell is going on. Oh. Okay, we'll resume in a bit. Right, there's been some developments since the last time. A guy on the Facebook, Don Superfo's Facebook group, I forget his name's Andy, I think. He said, well, maybe the RAM or the Z80 is the problem. Okay, so I popped in another Z80. I had it working and it got through the RAM test okay, so yeah, that was right. Except it started to do some very funny things with the keyboard. As in, it was ghosting keys that weren't being pressed, which was really strange. But anyway, this is the 3rd Z80 I've got in there now, so let's just pop that in. I've got the sound hooked up as well. So we'll go through the first startup test. This is what it's supposed to look like. Yellow border. Here we go. Now this is where it went wrong before. And it always went wrong on bit 3. And I thought, well, that's a bit weird. Changing the CPU, but I'm not sure how that actually fixes it. Because when, like I said, when I put the other one in, nah, here we go. So it's past that now. And here we are. And here it will sit. So apparently this is right. Okay. Now before I was getting to this point, and what it was doing was it was pressing number 1, even though there's no keyboard attached. So let's just unplug this. Plug in our funky glow-in-the-dark key map. Repro 48 case. Right, so this will go through the sequence again. And I'm wondering what is going on here, because this is a 3rd Z80. I don't think the others are knackered. They're 20 megahertz parts, and I think they're still good. And why did it go through the lower RAM tests? So anyway, let's see what happens when we get in here. There you go, past 2. There's a lot of foibles with this 3H Harlequin, I've got to say. Right, here we go. So now we're in, yeah? So we can go press 1 and you can see. Yeah. Look at that. So the test is reading okay. Problem with these keyboards is you've got to press them halfway through the floor. So that's okay. So caps and space to quit. Bam. What have we got here? 7. Let's try that. This is the first time I've done this. I haven't done it even off camera. So let's have a look. Ah, nice. Nice. yeah. Oh, there we go. Yeah, nice. All right, so that's all as it is. So it looks okay. Now, if I'm right, the ROM bank that brings it into 128K mode should be all opposite. So I've just switched that in. Let's there we go. Right. So what I have got in amongst my crap is an old Maxduino. So if we plug this in, hit the camera, which I said is on the gooseneck. So let's just unplug that while I do this. See, I've never used this cable before. I haven't got a mono cable, so I'm hoping a stereo one will be alright. I have no idea if this is going to work. I've not even tried this off camera. I don't have a Div MMC, so this is really the only way I've got to load it in. Let's load that up. And let's plug in a proper Pi power supply. There we go. Right, that's starting up. Nice. Maxduino 1.43, so it's quite an old version. So if we go tape loader, play again. It's a tap file. No, something a bit wrong there. So as you can see, or as I hope you can hear, it's coming through, but it's not working. So, oh dear. Let's try a different one, shall we? It's not even showing it. No, you should be getting the blue and red stripes now. Well, that's disappointing. Yeah, I don't know how I'm going to get around that. I haven't got, yeah, I don't have a mono cable to plug in, and I'm not even sure that's right, because in the schematic both lines look like they're joined together, I think. Yeah, the fact that you're hearing it suggests to me that there's a bit of a dodgy logic level going on there. So yeah, it's going to take a little bit of investigation. Yeah, okay, well, there you go. So we're basically mostly working. What we're going to do is leave it there, I think. This is an ongoing project, I suspect. I found a lot of different problems with it. RGB mode is not working, so I've got to investigate that as well. So I think I'll probably revisit this board in a later video. But yeah, so thanks to Neil for sending this from Retro4U, who sent me the PCB over, and I'm glad that I was able to fix his problem by finding my problem. Yeah, and again, thanks to PCBWay for supplying these to Neil in the first place. And look out for the next one, where hopefully I've got some answers to make this 100% working. Later.